welcome back to my YouTube channel. We're still under Mechanotechnics N4, which was still under simple gears, but this will be dealing with ring gear calculation. A simple ring gear calculation, it's when a pinion is matching with the ring gear internal. We're talking about internal, right? So if you have not subscribed to my YouTube channel, may you kindly subscribe to my YouTube channel and click the notification bell so that you'll be notified whenever I post a new video. Become the part of the family. All right, feel free to like and comment and to share this to your fellow classmate. All the best. So we've given this is we call this guys a ring gear. You see, if, initially we did something gears that are driving simple drive. You see, the gear was outside. We were driving outside. Now here we have what? The internal. It's internal. It's inside. We call this a ring gear. If it's something, this is a ring gear because it's acting in the inside part, internal, right? Okay. So nevertheless, we've given that refer to figure 5.6, which shows a pinion B with a teeth of fourth matching with the ring gear A. Here is gear A. All right. With the gear A. All right. We don't know what is those teeth. They just said gear A. Yeah, we are not given the teeth. They just said gear A. But gear B, we know the teeth of gear B. The inside one, the smaller one, is fourth. All right. So, as you can see, this is the pinion matching with the ring gear. Okay. All right. Hopefully you know 80. You see this is acting at the center. It's at the center of this until there. This is a center distance. Guys, this is the center distance. You see it's acting in the center there until there. It's a center distance. It's 80 millimeter. All right. So in says pinion matching with ring gear A, say the center distance in the shaft is 80 millimeter and the module of the teeth is 4 millimeters. Says calculate number one, the number of teeth on the ring gear. On the ring gear is the one that you've given. We are not given. This is a ring gear. On the ring gear, guys. The round one, this is the ring gear. All right, that is what we want there. Okay, the of gear A, we want that. How can we get that? It's obviously, guys, we know number one, we know we can say we want to find the gear of what? Want of the ring gear TA. So we know we've given what are we given? Let's take advantage of what we've given. We've given the center distance. We know that center distance is given by module divided by 2. But now remember, module it was is TA, right? Plus TB. But now, because this is a ring gear, guys, if you have something, this ring gear is acting in the inside, you don't use plus. Now you'll change the symbol, it will become what? Minus, right? But if you have a gears that are driving each other like this, they will have what? You'll have plus, you'll use plus. But if it's acting outside, they will use minus. Here we'll use plus. So we'll use minus because they're acting in the internal. So since it's acting internal, we'll use negative. So here will becomes negative. Do not forget that this will be negative. Are we together? TB. All right, like this. Meaning that you take the inner, the big gear, the ring gear. It's simply just a ring gear minus the smaller one, the ring gear minus the internal one, the one that is inside. All right. So we have the center distance. They said it's 80 millimeters. So we have 80 there. We've given that it's 8. Modulus, they said, is 4 here. Divide by 2. teeth we don't know is the one that we want to calculate. TB we've given. Of this, they said the teeth, there are 40 of gear B, 4 teeth. It has 40. All right. So you want TA. We do math. So you multiply them. You'll have 80 times 2. All right. Also, you divide by this 4 because this will be like this. After you have multiplied there, divide by 4 both sides. If you divide by 4 both sides, this and this will cancel. All right. So left with 80 times 2 over 40. This side here we have TA minus 40. So we take this to the other side, it will be positive. Is 80 times 2 divided by 4 plus 40 is equals to what? TA. All right. Are we together? Now, when you are adding, therefore, teeth A, if you punch this, supposed to get this will be what? 8. Because this will be 120 divided, okay, this is same as 40 plus 40. 80 times 2, it's 180 divided by 40, 40 plus 40, it's equals to what? This will give me 80 what? Teeth. We have the teeth of what? Teeth of teeth, 80 teeth. That is what we have there. All right. Now B, they say to calculate what? The pitch center diameter of the ring gear. How do we calculate pitch center diameter of the ring gear? Guys, the question there, this one is remaining the same, does not change. We calculate pitch diameter of the ring gear, which is its gear what? A. All right. So the formula won't change. The one that is changing is the one for center distance. Just the adjustment that we do is that the adjustment here we put minus instead of what? Of positive. We put negative is the one which will differ a little bit, but this one will be the same. Guys, we know that piece D is equals to what? Module multiplied by the teeth of the gear that we're focusing on, of the ring gear, which is teeth A. Obviously, we have calculated. We know that the modulus is the same throughout. If the gear are matching on the matching gears, when the gear are matching, guys, like this, they have the same modulus. As long as they are touching each other, they'll have the same modulus. Module will be the same. As long gears are matching, like they are touching, they are driving one another, doesn't matter. You see, they are touching here internal, they'll have the same module. The module will be the same. So we have 4 there multiplied by what? By 8. So this will simply give us 320. Remember, module it was 4 millimeters. Since we have used millimeters, this will be what? Millimeters 2. This is what we have there. So this is our PCD. All right. So thank you for watching. This is what we have in this typical video. Thank you for watching. Feel free again to like. Feel free to like and to comment and to share this to your fellow classmates. All the best. Thank you for watching.